Hey everyone, short week this week. Today is Tuesday, September 8th. So let's go ahead and dive right in. I know we just had the quiz last week. This week we're going to be talking about solving linear equations. It is a little bit different. So as you can see in this beginning here, we said, what is the difference? Expressions versus equations, right? This first one on the left is an expression, and we know that because there's no equal sign versus the one on the right. So I'm going to go ahead and solve both sides just so you can kind of see what difference there is. As you recall, with expressions, we typically use PEMDAS, right? Okay, one of the simplest ways that we can solve equations that people are familiar with is using PEMDAS backwards, or SADMAP. It's not 100% correct, but it's a good start if you know how to do that. And so then the biggest thing for students to remember is which one is which, right? Like, when do I use PEMDAS versus SADMAP that tells me the order of simplifying or solving? Well, if you look, expressions has the P early on, and so you could also say the same about PEMDAS, right? So expressions with a P, PEMDAS with a P early on, okay? All right. So let's go ahead and simplify this expression. This is something we did last week. We're going to first distribute the -2, which I actually didn't even check for the other things because I'm moving so quickly. But if I look at the parentheses, x and -3 are not like terms, so I cannot combine those, so I can't use parentheses. There are no exponents here, so I don't need to worry about that. So we're just going to go ahead and distribute. -2 times x is -2x. -2 times -3 is a +6. Okay, and then I'm going to start simplifying down just by combining my like terms. So remember that like terms have the same variable, right? Or the non-existence of a variable. So -2x and -5x gives me -7x. +6 and +8 gives me +14. And now I'm done because 7x and 14, there's nothing in common, right? Also, there's no equal sign. This is an expression, so we just simplified the expression. That's the answer. Okay, so now when I'm looking at an equation, we're going to do kind of the similar steps, but notice there's x's and there's a 0 on this right side, and that's going to come into play as we start to finish it up. So same steps, okay, same steps, at least initially. Okay, now we're going to go ahead and combine like terms again. Okay, so -2x and -5x is -7x plus 14 equals 0. Okay, so to this point, it looks really, really similar, except for this equals 0. So what that means is when you have an equation, you're trying to actually solve for x. Expressions, you're not. Okay, but when you're solving equations, you are. And so how do we do that? Well, once you get it simplified down to as best as you can right here. So this is the simplified version, right? We basically simplified the left side, which we almost split up into an expression. Now we're going to go ahead and use SADMAP, right? So we're going to do subtraction or addition first. What we mean by that is we're going to do the inverse. So since this is +14, and I want to get x by itself, my goal is to get this x by itself with no -7, no 14, nothing on that side. So I'm going to subtract 14 to the other side to get it out of the way. Okay, and I'm going to draw a line down the equal sign because when I have an equation, both sides must remain equal. So what I do to one side, I have to also do to the other side. Okay, so -7x, because these cancel, equals -14. Okay, again, I want x by itself. Well, right now it says -7 times x. What's the opposite of multiplication? It is division. So I'm going to divide both sides by -7, and that gives me that x equals -14 divided by -7 is 2. So as you can see, when you're solving equations, you should get to an answer, right? Like there should definitely be an answer in equations. Later on, we'll talk about when there are not solutions, but for the most part right now with equations, we're going to look at only those situations where there are. Okay, so why is it helpful to know how to solve equations? Well, sometimes, you'll just have an expression, but if you can determine a given value, right, to a solution, then you'll be in a good spot as well. So let's take a look at part A. Sometimes you'll have an opportunity to find multiple solutions. So one of the ways you can look at it is this says x equals 45 or 50. So I'm going to check and see which one it is. The first thing I'm going to do is I'm going to plug in 45 for every single x, and I'll see if that one works. And by works, I mean you can see, again, this is an equation, so that means the left side should equal the right side. Okay, so in parentheses, this is now 25. 2 times 45 is 90. 90 minus 15 is 75. Okay, so 75, because 3 times 25 is 75, equals 75. Perfect. So that one is a yes. Okay, let's go ahead and check 50 now. Oops. Okay, so we're going to move this off to the side. We're going to do the same thing, and we're going to check 50. So 3 times 50 minus 20 equals 2 times 50 minus 15. Again, all I'm doing is I'm substituting for all the x's the potential solutions. So I have 3 times 30 equals 100 minus 15. 3 times 30 is 90. 100 minus 15 is 85. So that does not equal, so 50 is not a solution, right? Okay, so we can do the same thing here. We can check both, -3 or +3. The other way that we can do it is we can solve it like an equation, which this one has an x squared, so it's going to be a little funky. So we're just going to plug in for these and see what happens. Okay, so 5 plus -3 squared equals 17. -3 times -3 is a +9. 5 plus 9 is 17. 5 plus 9 is 14. 14 does not equal 17. So -3 does not work. Okay, let's try +3. 5 plus 3 squared equals 17. 5 plus 9 equals 17. 14 does not equal 17 either. So no solutions on that, or neither in this case. Okay, so that's how you check to determine if a given value is a solution. You can just plug it in, see if the left side equals the right side, and if it is, then it is a solution. If it's not, then it is not a solution. Pretty simple. Okay, so let's go ahead and take a look. Now we're going to get a little bit more specific. When you're solving equations, you use the inverse operation. So just like up here, there was that +14, okay, and we use the opposite, right? The inverse. We subtracted 14. We had -7 times x, and then we did the opposite. We divided by 7. So same situation when you're solving all equations. What's the inverse operation of addition? It is subtraction. Okay, what's the inverse operation of subtraction? It's addition. So again, inverse means the opposite. So multiplication is the inverse of division, and division is the inverse of multiplication. Okay, so why is that important to know? Well, when you're going through and solving an equation, you have to keep both sides equal, right? And these are the properties of equality that say that we're allowed to do this. It says if A equals B. So what that means is if the left side is equal to the right side, right, then the addition property of equality says that you can add any random number to both sides and they'll still remain the same. Okay, as long as it's the same number. So like we did above, we added subtracted 14 from both sides. Same thing here, subtraction. So if I subtract it from A, I can also subtract it from B and it remains the same. Same thing for multiplication. If I'm multiplying it by A, I can also multiply it by C, as long as A and B are equal. Same thing with division. Okay? All right, so let's go through some practice problems, and we're going to justify each step with the correct property that you're applying. So if we add to both sides, we're going to use the addition property, right? Depends on what we're doing. So number one, first thing we want to do is we want to get x by itself. There's this -7 over there with it, so we're going to do the inverse operation. You can draw a line down through if you want to organize your thoughts. So we're going to add 7 to both sides, and this is the addition property. I'm going to shorten it up for right now. Okay, so you have x is left over on the left side equals 7's cancel. -15 and a +7 gives you -8. And since x is now by itself, we're done. So that was actually just one step. We just had to use the addition property. Okay, let's go to number 2. Number 2 has this -9 with the p, and p is the letter in this one, so we want to solve that. So let's get rid of that -9. We're going to add 9. So since we're adding, again, this is the addition property of equality. Okay, and p equals Negative 2 and positive 9 is 7. Again, since p is now by itself, the letter's by itself, we're done with that problem. Okay, number 3. Number 3 is a little bit tougher because you have this division symbol, right? Okay, well, what's the opposite of division? It is multiplication. So if I'm dividing by 5, the opposite of that would be multiplying both sides by 5. Okay, multiply both sides, right? Okay, and that would be the multiplication property of equality. That cancels the 5s because it was multiplying and dividing by the same number. And then on this other side, 11 times 5 is 55. Done. Okay, so just one step. Number 4, negative 8 times x. This is one that most students will do this. But the problem with that is the negative symbol is not in between right here. It's out front. So that tells me this is negative 8 times x. So what's the opposite of multiplication? The opposite is division. Okay, so x equals negative 9. And this is the division property of equality. Okay. So, what about rational numbers? Well, as you kind of just saw, we just divided by 5. A rational number is when you have a fraction. So it's very similar to division. What this is saying is that we have 2/3 times x, right? Well, if we wanted to do the opposite of multiplication, we would divide by 2/3. But that looks really complicated to divide 2/3 by 2/3 and do it again on this other side. So instead, we do something called multiplying by its reciprocal. Okay, so instead of dividing by a fraction, we multiply by its reciprocal. So what that means is we're going to multiply by that fraction flipped. As you can see, I had 3 on the bottom here, now it's on the top. I'm going to do that to both sides, okay? And remember, any whole number is the same as that whole number over 1. Okay, so 4 divided by 1 is still 4. So that doesn't change the number, we're just making it a fraction so that we can multiply fractions a little bit easier. Okay, so on the left side, this cancels out. I'm left over with x equals, okay, and then 4 times 3 is 12. 1 times 2 is 2, and then this actually simplifies. 12 divided by 2 is just 6, so x equals 6. Okay, so multiply by the reciprocal. All right, so let's do the same in number 6. The reciprocal of 4/5 is 5 over 4, or 5/4. I'm going to do the same thing over here. Since it's just a whole number by itself, I'm going to put it over top of 1 and multiply. The left side cancels out. X equals 10 times 5 is 50. 4 times 1 is 4. 50 and 4 both have a 2 in common, so 50 divided by 2 is 25. 40 divided by 2, or 4 divided by 2 is 2. And so x is 25 over 2, or 12.5. Okay. All right, on to the last one. Number 7. Again, we want to do the opposite of simplifying. So with expressions, we were using PEMDAS. Here we're going to use SADMEP. So we're kind of working backwards. Instead of multiplying by the reciprocal first, we have to get rid of this positive 5 so that the fraction is the only thing left on that side with x before we can multiply by the reciprocal. So we need to subtract 5 and get it out of the way first. Okay, once it's out of the way, and that cancels out, now I have 5 over 2x equals 25. Now I can multiply by the reciprocal. Okay, put this over top of 1, multiply by the reciprocal. These cancel. I'm left with x equals 25 times 2 is 50. 5 times 1 is 5. And this simplifies to just 10. So x is 10. Okay. So there's a few more practice problems here. You can go ahead and start those. Your homework tonight is going to be at the bottom. It is these 4 questions. Notice that you need to solve for y. So at the bottom of this one, you're going to have y equals. At the bottom of this one, you're going to have x equals. This one, you'll have d equals. And this one, you'll have y equals. And don't forget, as you're going along, just like we did up top, justify your steps. So what properties did you use along each step? Okay? Good luck. If you have any questions,